Okay, so let's get started, guys. So my name is Rodney Joyce. I'm a data and AI consultant. I think I've met some of you guys before. This course, or this tech talk, is going to be called Data Science for Dummies. And it's only called that because I'm a dummy myself, and this is the way I like to learn. So I try things and I share it to help my understanding. We're going to focus on a very classic machine learning problem that's kind of the hello world of machine learning. It's called the Titanic survival prediction. And the tech stack we're going to use is Chris's favorite, actually, Databricks, Python, and SparkML. Okay, so I'll go over the agenda quickly. We'll just look at what we're going to be doing here. We'll do some more boring theory on data science workflow. We'll do a lot of demos. So there's going to be lots of technical demos, a lot of code. So let me know if I'm going too fast, please. I tend to talk too quickly as well. We'll do some machine learning theory. It's going to be very light. The focus of this talk is more on the data engineering side and less on the complicated mathematical algorithms, because I'm not an expert in mathematical algorithms. And then we'll actually predict the survival outcome on the data set. We'll do takeaways and questions. So if you don't know what Kaggle is, it's a competition site focusing mainly on data science. And the reason why they choose the Titanic business problem is that normally you need domain knowledge to solve a problem, and that's especially so with a data set. So with Titanic, it's a very small known domain. We all have heard of the Titanic, I hope. If you haven't, you probably shouldn't hear. So Kaggle.com is where the competitions live. You can register, you read the competition blurb, you download the data sets, you use whatever tool stack you want. They might stipulate requirements or limitations. You just have to adhere to those. There's no requirements on this one. It's purely for practice. And then you do your prediction and you upload the result set, which is very technology agnostic. So it's just a CSV file with 2 columns, passenger ID, and whether they or not they survived the Titanic disaster. It's a bit morbid, but just bear with me. And then Kaggle will rate your submission and tell you where you are on the leaderboard. So it's up to you how deep you go in feature engineering and what models you use for training, what data sets you use, what machine libraries you use, machine learning libraries, to increase your accuracy. So as I mentioned, we're going to do machine learning to predict which passengers survived the tragedy. This is a binary classification problem. So there's only 2 outcomes. They either survived or they didn't. It's 1 or 0. So it's stupidly simple. Your score is based on the percentage of passenger outcomes correctly predicted, which is known as the accuracy. There are other ways to measure metrics of a classification model, but accuracy is the most common and easiest to understand, so we'll just stick with that. And we'll zoom into the Kaggle competition, but it'll give us more detail on what we need to do. So I'm a bit of a Databricks fanboy, so we're going to use Databricks for this, and we'll use Python, because Scala's too hard, and we'll use SparkML for the machine learning side of things. I've actually done this as well with Jupyter notebooks and Python and NumPys and Pandas, and it was a lot simpler because NumPys and Pandas are Python libraries that make machine learning really easy. But I wanted to use native Spark because it's distributed, so it can handle huge scale. This obviously doesn't need scale. It's 1,500 records in total. But if you're doing the same problem where you needed to scale across, 1 million records, 1 billion records, you need to have that scale behind you. And Pandas only works on a single cluster. It can't parallel process. So NumPy will not work in numbers, and Pandas wouldn't work in that situation. So we're not using them. Just a reminder, it's going to be very technical, and we're focusing more on data engineering than the maths. Okay, so this is actually part 1 of, I think it's 7-part series. The second one will be the same problem, solving the same problem, but using the Azure Machine Learning Studio, which is a GUI service in Microsoft Azure. It's very simple, drag and drop things. I'm not sure it really serves a purpose, but we'll do it anyway. At some point in the future, we'll do one with Databricks and the Azure Machine Learning Service. So the names are pretty confusing. Azure Machine Learning Service is a service on Azure that basically handles the operationalization and deployment of models. So how do you keep track of what training you've done, which models you've deployed, which have the best accuracy, how do you containerize them and deploy them to the edge or wherever you want to deploy them. So that's all built into the service for you. So it's kind of machine learning as a service. That's very exciting stuff. Part of that service is actually a thing called AutoML, which is why I'm not focusing on the maths, because traditionally I do the engineering side, then hand over to a data scientist to do the math side of things and choose the best model. But in the last few years, AutoML has become a thing where it's kind of data science as a service where someone will go, the algorithms will go through and choose the best model based on what you're doing. It'll try different features, it'll create different observations, and it'll work out the best model for your problem. So we'll give that a go as well. MLflow is Databricks' machine learning offering, and I haven't actually looked at it, but I'm such a Databricks fanboy, it's got to be good, so I'm going to give that a go as well. There's a product called Data Robot, which is very similar to AutoML, so it's data science as a service, and it looks very smooth. I'll give that a go as well. And then the last in the series will be focusing on the deployment, the DevOps, and operation, I can't say that word, of machine learning. So how to deploy these things and make a pipeline out of it, which is actually probably one of the hardest parts, to be honest. Does that all make sense so far? Cool. So data scientists spend most of their time cleaning and organizing data. So if you look at this chart, you'll see that extracting data is the second biggest time thing. And then at the very top, we've got refining algorithms, 4%. So it's not actually as sexy as some people might think it is. I know Greg thinks data science is pretty sexy. But the real hard work is done in the cleaning and organizing, and you'll see that reflected in this talk. You'll see how much time we spend in prepping the data. Okay, so the data science workflow, we've got data coming in on the left-hand side, and we've got value coming out on the right-hand side. Obviously, we're trying to get return on investment out of this whole thing. That's why we're doing it. So first of all, we're going to extract the data from whatever data source we have now. It could be coming from APIs, it could be coming from storage accounts, it could be IoT data being streamed in, it could be coming from anywhere. In our situation, we're just going to upload 2 files onto blob storage. The next large process is the organization step, and this is actually made up of a few different subsets. There's exploring and understanding the data set, which is really where the domain knowledge comes in. So it's pretty common. You go to a new role or a new project, and they give you a data set, and you've got to quickly get up to speed with what's going on. You've got to understand what the different columns of the data set means, and there's all these kind of obscure business rules. So exploring the data set helps understand that. Data munging is the scientific term for filling in all the blank values, get rid of extreme outliers, fixing incorrect values. So data never comes to you in a perfect condition. It's always full of errors and full of problems. So you've got to work out what the problem is and how to fix it best. We'll explore these later in detail. I'll start to get a bit more interesting. Feature engineering is very domain specific. So what features out of your data set would make sense for the problem you're trying to solve? So for example, in the Titanic, we've got information in this data set, which I'll show you. It's things like the class they were in, first, second, or third, their name, their age, the fare they paid. Now, if you start thinking about the domain of the Titanic, I showed this to my wife, and she was like, surely if you knew where they were on the ship and if they were drinking or not, they would help predict what they were doing. And she's completely right. If we knew exactly where they were on the ship, that would really influence the probability of whether they survived or not. But in 1912, they didn't have GPS trackers or tile or whatever, Telstra's new location of things thing. So we don't know that. We've got a very limited set of data points, and we can infer some features from those points, but we are limited to that data that's coming in. This is a very iterative process. So, or if I'm keeping you awake, just let me know, man. So if you think about this, we could present the findings to someone, and they could say, well, I actually have another bit of data I want to add, and you could feed that back in and rerun the process and improve your accuracy. So it's not, you don't just do this once, you do this many times. You're constantly showing the visualizations to your stakeholders throughout the process, because we all know that a lump of data is hard to visualize, especially if it's JSON. So seeing graphs that make sense of what you're looking at really helps explain the problem to other people. Getting even more exciting, we've got the analyzer model, which is the actual machine learning. So we take all this data and we analyze and model it. And this itself is an iterative process. We keep looking to improve our accuracy, and then we present the data, which hopefully gives us better ROI, and we can do something with it. So obviously in Newcrest and the big mining companies, a 1% return on investment on the efficiency of a crusher could be millions of dollars. So it doesn't really matter whether it's 20% or 1%. It's how valuable that is to the business in that particular domain. In this case, someone could have lived or died, so it's probably pretty valuable. And then this whole workflow is iterative. So you might do this multiple times as new data sources become available and online, and as the domain becomes more clear. Okay, so we'll go into a quick demo of extracting the data. So let's go across to. I didn't prepare something. Okay, we're going to open Kaggle. Okay, so this is the competition I mentioned. If you look at the overview, it'll tell you a little bit about this, and in the more advanced competitions, you can read this to get better domain knowledge. There might be clues or tips that might help you understand the dataset more and which features to use. As I mentioned, it's a binary classification problem, so there's only one, so there's two classes, true or false. You could use any technology, not necessarily Python or R. And then it talks about how it's going to evaluate your submission. So the metric that it's scored upon is accuracy, and it tells you the format that it needs to be in your input file. Now, the data comes in two sets. Normally, they might just give you one set, which is just the training data. We know the outcomes of the survival rate in the training set, but we don't have them in the test set. So what they're basically saying is train on your training set and then run your test set through the same model and upload it to Kaggle, and they'll store it. Okay, if we look down, we'll see the data dictionary for this domain. It's ridiculously simple. Okay, that's not too bad. It won't be long on the site. So I'm just looking at the kaggle.com website. If you can't see my screen, there's a data dictionary where it talks about each field in the data set, what type it is, and what it actually means. So there's some interesting things here like age, in their family, and then it's got the two files. So I'll skip this step. I literally just downloaded these two files and I uploaded them to Blob Storage. So I'm now looking at Storage Explorer. I've got so here's the test and the training set. It's just a normal Blob Store on Azure, and this is where I can connect Databricks to talk to this.
So the only one,
okay,
Hi guys, we can hear some feedback from someone else.
Mute their mics, please, if you haven't done so. Ollie, can you see the presentation now?
Yes.
The presentation? Yeah. Okay, cool. Okay, so we downloaded the files, put them in the blob. Now, we're actually going to concatenate the two files together. So even though the training set has got 80% of the records, if we use the test set as well, we're going to get more data. So we're going to get better results and better, less generalized or more generalized accuracy. So we're going to concatenate them. Obviously, some of them don't have survived records. And I'm going to switch over to Databricks for the next demo. Okay, so in Databricks, which I assume you're all familiar with because hopefully you watched my last tech talk. Can you see the screen, Ollie, the website? Okay, so I've got an ML cluster here. If you go into this guy, you'll see that it's the runtime is the 5.3 ML. So Databricks have a build that has certain ML libraries on. So it's got TensorFlow, Keras, SparkML, obviously, scikit-learn. There's a whole range of things. It saves you having to install them. So I just use that runtime, and I've bumped it up to a massive 14 gigs, which hopefully won't break the bank. We'll go to demo 1. Okay, so I'm going to go through these quite quickly. Please slow me down if I go too fast. So firstly, we're going to just connect to the blob store. Okay, don't worry too much about that. And we're going to read those CSV files into a Spark data frame. So we've got the test.csv file and the train.csv file, and we just read them in. We infer the schema. So you'll see that Spark read them in fine. The test dataset has one less field in the train dataset because it's missing the survive column. So yeah, there's no survive column there. If you look at the type of these variables, even though Python is dynamically typed, you'll still see that it does infer the type. So it thinks it's a PySpark.SQL dataframe. So we're not using pandas here, otherwise that would be a pandas data frame. This is a native Spark data frame. This isn't even a Databricks data frame, it's a Spark data frame. Okay, so we're now looking, that's the extraction part done. If we flick back to the presentation, we're now in the EDA phase, exploring the data, okay? So, we'll just have a quick look around and see how many records are in each of these guys. So there's 418 in our test data set with no survived outcome, and there's 891 in our training data set, okay? This syntax is basic Python, but it's actually PySpark Python. So, for example, in Python, you don't have the brackets there, but this is a PySpark flavor of Python. This is similar to string interpolation in C# where you can put variables into it. So there's the outcome. There's 1,309 records in total in both data sets. Now, if you want to see the basic structure, I want to see how many columns and features there are. So in a data set, it's like a table. The columns are features, and the rows are observations in data science speak. So we'll just do a dataframe.show, and we'll see, it'll only show the top 3 rows, but in the test data set, these are the features, and here's the data. So we've got name, we've got the class they're in, we've got the passenger ID, we've got their gender, their age, if they had siblings or not, if they were a parent, ticket number, how much they paid, what cabin they were in, and where they embarked, the port of embarkment. The training data set's exactly the same, but we know that the people survived, so we're going to train a model on that. I don't like the .show command. I prefer the display command. It's a Databricks thing. It shows this in a nice table. You can sort the columns, and you can also change to different graphs. So this is just the same information. And you can use .print schema to visualize the schema, which is similar to the thing we showed above. So you should see that the training data set has the survived, whereas test doesn't. Should I make the font bigger?
Yeah.
Okay. So as I mentioned, we'll concatenate these two data sets together. So the reason we're doing this is to get more data for our input, which will result in more accuracy in our model. If we're using pandas, this will be really easy with the .concat function, but with native Spark, you actually have to have the data frames having the same schema. So we have to add a dummy column to our test data set. It's called survive, so that the schemas now match. And we're just going to give it a literal value of -888. This is so that later we can split them again, and we know which ones were from the test data set. Does that all make sense? Okay. So now we look at testing. You'll see it should have the survive column now at the end. So now the schemas match. Even though the order is different, that doesn't matter. Spark can handle that. They are the same columns in the data sets. Now, I'm not going to go into detail on this code. Basically, when you concatenate two data frames together, It does logic on as to whether they've duplicated or not, and Spark does it in a bit of a complicated fashion. So we're just going to run this, and basically it's making a function to take into data frames and return one single one concatenated. So we're going to run this concat, and we're going to do a count on this new data frame, df. So now we have 1,309 observations, which we expected, and we have one data frame. Bear in mind that data frames are immutable in Spark, so we can never change the actual data frame itself. It'll always drop and recreate it, or you'll infer a new data frame like this. So test df and train df still exist, but we made a new data frame, and now we're working on that one. Okay, so for each column, let's have a look at how many missing values there are. Now, I'm just going to show you how pandas works with Spark, because it is useful to know. So it has this function called toPandas on a Spark data frame, and if you look at the type of this df pandas, you'll see that it's going to be a different type to the other one. Thank you. So it's pandas.core.frame, the data frame. It's no longer a Spark data frame. So it has a different set of methods. So pandas comes with a very nice little info method, which gives you the total number of records, how many features there were, and how many non-null values there were. So for example, we can see immediately that Claire's missing one record and Cabin's missing a whole stack. And it also tells you what type they are and how much memory it uses up. Now Spark doesn't have a method quite like that. I'll show you something similar later. We can also do basic filtering, sorting, and searching to learn more about passengers. So we could say, let's see all the first-class female passengers. So we're back to the Spark data frame, and we say, show us all the passengers that are female who are in first class. And we just print that out. So there were 144 female. There's actually a bug there. I don't know if anyone spotted it. I just saw it right now. That number is the total passengers, not the total female passengers and total first class passengers. So anyway, you get the idea. There's 144 females. We can also do things like sorting. So this is a classic import statement, same as in C# when you import libraries at the top, and we're importing the desc function from the PySpark.sql functions library. We didn't actually use it. We just took the first 5, and down here we can say, so Spark can chain methods together. So start with the data frame. There's our first class data frame for first class females. We're selecting these two columns, which is like a select in SQL. So we want the name column and the age column. There's also another bug there. I'm just going to fix that very quickly. The select method just takes an array of names. So it didn't mind that I had the df column there. It still just treated it as a name, age and name. They just happen to be the same in both data sets. And then we're going to sort by the age. And we're going to sort descending, and then we're going to display that. Okay, so here's our females, and then the oldest one in first class was this lady here. Okay, we're now going to write our concatenated data frame back to blob storage. Sorry, not to blob storage, to the Databricks file system. So we could write it back to the blob storage, but we don't need it. We've got this temporary storage area in Databricks called the Databricks file system. It's based on HDFS, and it's just kind of like a temporary dump zone. So we're going to dump this back. So it's df, which was concatenated, and we're going to call it Titanic df raw in Parquet format. So Parquet is a ridiculously good compression algorithm. So I'll give you an example. Recently I was playing around with I had 5 million records in a CSV file, which was something ridiculous like 1 gig in a CSV format. In Parquet, it was 20 megs. And it can read very quickly. So it's commular compression. So it does pretty smart things. Okay, so that's exploring our basic structure. We'll go back to our presentation. So we've actually did this in a bit of a reverse way. So the first step organized was EDA, exploratory data analysis, and the first step was basic structure, which we've done. I'll just go over this quickly. How many rows there were, we did that. How many columns there were, what are the types, how complete is it, the filtering, sorting. The next step is summary statistics. Now, these help summarize the data in an overall sense and help you understand the data. So it works different ways depending on whether it's a numerical numerical feature column or a categorical feature. So numerical features where the data has intrinsic value, like the age of someone. It's 10 is higher than 9. Okay. A categorical feature cannot be measured. It's like a class. So in the Titanic situation, they boarded at, let's use where they boarded. So they boarded at Southampton or Queenstown. You could convert that to a 1 and a 2 or a 3, but there's still no intrinsic value in that number. One is not better than the other or higher than the other or sorted. They're not ordinal. So that's the primary difference between categorical and numeric. So we've got a couple of numerical features in this data set, and we've got a couple of categorical features. So looking at the numerical features, one of the summary statistics that we can use is the centrality measure. So this is basically one number that helps you describe the data. So the simplest way to think about this is the mean or the median. So mean is average, exact mathematical word for average. And if we've got 10 people, take the number of people, sum of the ages divided by the number of people. Okay. The problem with mean is that it's prone to extreme values. So let's say we had 10 people and we had 9 1-year-olds and we had 1 100-year-old person. The average is 50 something, which is not a true reflection on the data set. We wouldn't say, oh, there's 10 people and they're roughly 50 years old. So even though that one number describes data set, its mean can be skewed by outliers. The median is the middle point of the sorted list. So you take the 10 people, you sort the list ascending or descending, doesn't matter, and you've got 10 and you've got all your ones at the bottom, and you take the middle point, which should be 1. So now your single number is 1. So the median and the mean are very, very different. And the median is far more accurate because it ignored the extreme outlier. Does that make sense? Okay, the dispersion measure, it looks at how things are spread out. So we can tell, in that example I used with all the kids who are 1 and the elderly gentleman, the spread it's not really spread out, it's all 1s. And then there's 100 over here. So it's highly dense over here and 1 guy over here. We can also look at things like range, percentiles, variances, standard deviation. I'll show you these more in a demo. It'll make more sense. Categorical features, we can't do things like median and mean because we don't have the number. We can't say the average of Queenstown and Southampton is Southampton. There's no average. But we can look at things like the total count of the unique values. So we might, in that example I used, in this data set, there's 3 embarkment points. There's Queenstown, Southampton, and Cherbourg, I think it is. So the count is 3, the unique count is 1. So it's actually 3. There's 1 per each embarkment point. The per category count, we could look at things like, if we use another categorical feature like the title of a person, whether he's a Mr. or a Mrs., we could say that there's 100 people with titles, 50 of them have the title Mrs., 50 of them have the title Mr. So we've counted the number of each category value there. And then we can look at statistics per category. So in that same example, we could say for the Mrs., the average age is 50. For the Mr., the mean fair price was X. Okay, so now we'll flick back to the demo and I'll show you these in action. Waiting for time. Okay, so first thing we're going to do is we're going to reload the data frame that we saved to Databricks, and we're going to cache it just so it speeds it up. And you'll see It's the same. It should have the survived column because we added that, and it should have 1,309 records. So we're going to look at numerical features only, and we look at the centrality measure. Let's look at the mean. There's a Databricks method called describe, and it's going to give us a nice view of the. Sorry, let's get rid of that show. Display. Okay, so this basically has all the columns at the top, the features, and then down here it's got statistics. So it's got the count, and you'll see this is the count of non-null values. It's not the total count. So here for cabin, we've got 295. So this is a very similar method to the pandas info method. It's got the mean for each column, so passenger ID. So this, for example, makes no sense. Passenger ID is not actually a numerical feature. It's a categorical feature because passenger ID doesn't have an intrinsic value. You can't say the average passenger ID is this because it's an identifier of the passenger. Class again is a categorical feature, not a numeric feature. Does everyone understand that? Even though it's an integer, it's not actually a numerical feature. It's a categorical feature. It's a state that the data is in. It's either 1, 2, or 3. You can't have mean on a string value, so it gives out a null. The mean age is 29.8. Yeah, so you get the idea. Standard deviation, it shows the standard deviation for each column. It shows you the min value. So let's look at a numeric feature like fare. So fare is the amount they paid. Someone got a free ticket. Maybe it was Leonardo DiCaprio in the movie. And someone paid 512, I assume that's dollars. It's a lot of money in those days. And what other numeric features do we have? That's probably about it. Okay, so this describe method is very nice for a quick overview of the data set. We can also use individual functions. So, for example, we'll get the mean of the age, and you'll see it's 29.88. And if you compare that to the describe method, you'll see it's the same. So describe was just a handy way of getting an overview of the whole data set. We can do individual functions here. Not so useful in isolation like this. The median, it's funny, this is one of the things that in pandas was ridiculously simple. It's just dot median. But in Spark or Databricks it's a little bit harder. So we have to use this thing called approximate quantile, and we pass in the column that we're interested in, and we say we want the 50th or 0.5 quantile with no deviation. And the median is 28 for age. So if we compare that to the mean, they're not too dissimilar, which means there's not too many extreme values. So that's not terrible. Okay, the dispersion and the spread and the measure, how far out are things from the central value. Range is basically the max value minus the min value. So if we use fare, the amount they paid, let's look at the min, the max, and the difference. So we know from above that it was 0 and 512, and therefore the range is 512. So there's quite a lot, big spread there for fare. But range isn't showing the density; it's just showing the range. Percentile will show the distribution of data points. This is more about density. So there's a very nice way of showing this with a box Whisker plot. So basically, it shows the 4 quartiles: the min, the 25th, the 50th, and the 75th. So there's actually 4 buckets there. There's 0 to 25, 25 to 50, 50 to 75, and 75 to 100. And get it using our median function, and we're just passing in the right attribute here. So here's our the different quantiles for fare. And then we now have in Databricks, you have the ability to show a box plot. So if you're using Jupyter Notebooks or Azure Notebooks, you'd probably import matplotlib library from Python, and you'd do a box plot. But we've got this built into Databricks. All I did was display the fare, and I set this plot option to be a box plot, and I set it on fair value. Now the way this works is that this line in the middle is the median of fair. So that's the 50th quantile. Okay, it's also the median. The first line here is 0. The next one's 25, and this one here is 75. This line on the right-hand side is the 100. All these dots here are outliers. So what it's done is, basically it works out in this plot that anything more than the interquantile, I think it's called, is anything more than 100 is basically an outlier. So I think there's even one right on the right-hand side. It's off my screen. There's one that's 500. Oh, there we go. So you can see that there's a very extreme outlier there, and then there's a couple more over here, and there's a couple more right close to here, and then the bulk of them are inside here, the averages, or the median, sorry. So the box plot's a very nice way of seeing distribution and looking for those outliers. We could take that value, 512.33, the fair value, and we could look up in the data set who paid that amount. We could also use show me all the fares where the fare is the max, and we could see more about that person and try and work out why they paid more. Maybe it's an error, maybe it's not. Okay, the variance. The variance is how far everything is from the mean value. So I'm looking at the variance for fair. I'm not going to go into the maths details behind this because I don't really understand it. It's var underscore pop. It's a built-in function, and I'll give us the variance. Standard deviation is the same, but it's the square root of variance. So 51. And if you remember, if we look up above where we had the describe function, we had the standard deviation for fair 51. So we would expect that to match, which is good. Okay, now we look at categorical features, which are probably a little bit more fun. Let's look at the total number of records there were. How many records for embarked are null and how many are not null. So we have 2 values missing, and we have 1,307 that are not null. We can count the number of unique values for embarkment and gender. So there's 3 unique values in gender. Embarked. There's 3 I mentioned: Queenstown, Southampton, and Cherbourg. We can group on embarked and then do a count, and then order it by that count. So now there's a 4th state which is null, okay, which we obviously have to fix. And we can see that most people got on at Southampton. Maybe it was where the boat launched or whatever. You wouldn't think this had an effect on the outcome of survival, but possibly it did. Maybe the people who got on first got the best cabins, or to higher up, or maybe not. That's the domain knowledge that you would have to know from your business analyst. If we look at gender, we've got 843 males, 466 females. So it's kind of interesting, quite a skewed towards males. And then we can look at the proportion as well, which is the percentage. So we've done a windowing function. We've grouped by sex, done a count, and looked at the percentage of the sum of the count over divided by the sum. So 35% were female and 64% were male, which is the same as the count, really. And just showing you some more fancy graphs with a Databricks built-in plotting function. We can see this on a pie chart, or we can see the distribution of class on a normal bar chart. So 223 people were in first class, 709 were in third class, and some people were in middle class, second. Okay, so next we have distributions. We looked at this briefly in the box plot, but it depends on whether whether you're looking at one feature in isolation or multiple features. So univariate when you want one feature. In the box plot, we did box plot on fair, and that showed us those outliers, the person who paid so much. We could use a histogram, which basically puts the data into buckets or bins. So it's like a bar chart, but it says if we've got all the ages from 0 to whatever the max age was, we're going to put them into buckets of 20 and group them. Otherwise, you'll get a lot of dots per record, and that's very good at showing the skewness of the data, whether it's leaning towards the left or the right. And I'll show you that later. Kernel density estimation plot. It's out of scope. It's similar to the histogram. If you want to compare more than one feature, which is pretty common, you want to say, show me whether or not the embarkment point did in fact have an effect on survival rate. You can do that with a scatter plot. So it shows it's very good at correlating data. There's also charts and ways of looking at more than 2 features, which starts getting quite tricky. We'll leave that as out of scope. Okay, so let's click back and do that in Databricks. You can see I'm only on demo 3, so we're going to have to speed it up a little bit. So first of all, we reload our data set. We didn't actually save anything in the last demo, we just looked at the data. So the univariate demo, we'll just look at a histogram for age and fair. Okay, so okay, so this is using the display method, and I've set it to be a histogram, and I've said there's 20 bins. I could change this to 5 bins, and you'll see it'll group. So that helps you see where the data is distributed. There's not many elderly people on this boat. Mainly it was very young children and 20 to 30-year-olds. So that's the histogram. Let's see what everyone paid. So the fare, definitely under 50 was the most common fare. So you can see it's a very nice way of visualizing the distributions. There's a function for skewness, but it's unless you're looking at the maths, that's probably not very useful. The visualization is easier. For bivariate, comparing 2 features together, we'll use the scatter plot. So again, we use Databricks' built-in display method, and we can compare fare to age. So maybe elderly people had more money, so they stayed in first class. It's possible, but this is a bit of a dog's breakfast. You can't really tell much from that. Let's look at if there's correlation between the amount they paid. Sorry, that was age to fare. Yeah. Now we're going to look at fare to class. So we can see here that people who are in, this is pretty obvious, people who are in first class paid more, which is what you would expect. It's economically. Bit disappointing that one, but you get the idea. Okay. Okay, next we'll look at grouping and crosstabs and pivots. So this is easier to demo. Go back to Databricks. We've done a bit of grouping already. Sorry, a bit of naming convention problems there. Okay, so we get our data, and let's say we want to group on gender, but we want to know the mean age per grouping. So here we can see the average female age was lower than the average male age. Okay. Now let's group on where the passenger boarded, so the embarkment point, and the class of ticket, and want to see their average age and fare. So we've got a multiple column group by. That's fine. So it'll handle that. And then we want to pass in different types of aggregations. It's quite incredible to do this in one line in Spark. We want the mean fare, the min fare, the max fare, and the mean age. So here we've got, let's look at Southampton. People who got on at Southampton in first class, the average fare was 72. Someone got on free, and someone paid 263. So it's the person who paid 512 got on at Cherbourg. And the average age of the Sherberg embarkees and the class was 39. So this is a very nice way of seeing whatever metrics you want, and there's 101 different functions you can aggregate on. Count's the easy one, sum, mean, median, fair, sorry, not fair, max, min, there's all sorts of things. So crosstabs are very useful for showing relations between two different categorical features. So if we want to look at gender by class, we can see that the distribution of male and females across first, second, and third. So let's see. In first class it was almost 50-50, but then in third class it doubled. So maybe they were workers leaving to go work in somewhere. You know, that comes down to domain knowledge again. You can look at gender and class as a visualization. And I mean, that's the exact same information, but you can see how that stands out now. It was much easier to spot than spotting that 400 was bigger than 216. So visualizations are a very nice way of quickly getting information out of data. Pivots are for numerical features. Well, that's not strictly true. It's like a crosstab, but you can look at aggregation. So whereas this guy's showing the count. This is the number of males in first class. With a pivot table, we can look at other aggregations. So we could say, I want to see sex by PC class, but I want the mean age instead of the count. So the average male in first class was 41. Okay, that is the end of the exploratory data analysis. That was the biggest part. So that was similar to where a data scientist would spend most of his time. Data munging starts getting more fun. So we'll look at missing values first. Yeah, so maybe it's a machine error. Maybe it wasn't actually known at the point in time. It wasn't available for some reason historically. Maybe there was an IoT sensory imbalance, but for whatever reason we have missing values. Okay. This leads to inaccurate analysis. It could skew our results, and we could go and make decisions based on that outcome that's incorrect. Also, a lot of models won't work with nulls. They have to have all the values there. That's the main reason. So we could just remove the observation and delete it, or ignore it. Generally, you'd do that if you had more than 40% of your observations are missing. So, for example, with cabin, we had 285 out of 1,309 that we didn't have. So it's like we could have a guess at what cabin they were in, but it's probably going to be wrong. So let's just ignore it. We can also replace the value, which is the most common. So you impute it from other features. So for example, or we'll go into a detailed example. Outliers we've already looked at. They're extreme values and they can really skew your machine learning. It's where the values are different from normal. The solutions are quite similar. You can ignore them. You can choose to keep them and just let them affect your model, because that might be healthy. You can use binning to recategorize them. So binning is like we saw in the histogram, where that person who paid 500 as the max fare, we could say, let's put the bins into low fare, medium fare, high fare. And we'll group those guys together. So there's no longer that extreme value on the right. It'll only be the three guys grouped together. Transforming it is when you apply a calculation to it to normalize it to a low value. And imputation is the same as in missing data, where we think it's an extreme value and it could be incorrect. We're going to compute something different. Incorrect values are similar to missing values. It's very hard to know if a value is incorrect. You need the domain knowledge. I can't tell if one of those values is incorrect. The fixes will be very similar to the previous one, so we'll just ignore that for now. One more time. So, where were we? Okay, so we're going to load the data again. So we're going to fill the missing values that are null. Now, for numerical features, we can use median imputation, which is basically where you take the median of all the other ones that you have, and guess that it's probably going to be that. We don't want to use the mean or the average, because we saw how that's affected by extreme values. For categorical features, we use mode imputation. So if we've got 100 records and 80% of them came from Southampton, we can guess that with a higher probability that the missing one would be Southampton. So look at the highest frequency of the other values. There's more advanced things like forwarding and backfilling. So maybe in IoT data where you've got a sequence of data and you're missing one at the end, you can probably extrapolate the trend and fill it using that, forward and backwards. And then you can use, of course, predictive modeling to work out what it could be, which is kind of what we're doing here. So first of all, let's just remind ourselves which rows in this data set have missing values. So I'm going to switch to the display feature because the screen's too small and it's making the values bunch up. Okay, so we know we've got 1,309 records. So wherever the count is not that, we have missing values. So age is missing a couple, and cabin's missing a lot, and fare's missing 1, Bart's missing 2. So here's a nice little way of counting where you loop through all the columns in the data set, and if a value is null or is null, we count it and show it. So it's kind of the inverse of what we just saw. So age has 263 missing records, cabin has 1,014, fare has 1, and Bart has 2. So if we want to use any of these features in our machine learning model, these have to all be 0. We cannot put nulls into our machine learning model. Okay, so I'm not going to detail on what that does. This is another way of looking for the same thing. It's counting the number of nulls in each field and only showing the ones that have nulls. So we also want to have no output here to note we have no nulls. Okay, so as I mentioned, cabin's missing a whole stack. We don't have the domain knowledge to guess it. Let's just drop it. So let's look at fare. We're only missing 1 record. This person got on in Southampton. He's from the test data set because we don't know if he survived or not. We don't know his cabin. We don't know what he paid. And he's in 3rd class. Okay? So what we'll do is we could say get the median of the age for all passengers. Or we could say get the median of the age for male passengers. We could say get the median of the age for all male passengers who were in 3rd class, who got on in Southampton. I don't know if Southampton would have an effect on age. Maybe there's an LD population there. The point is, domain knowledge comes in again here. We'll make it as specific as possible. We'll see the median of all the other fellow passengers in 3rd class. Okay, so it was 8. Okay, so a lot of low people, and we'll use this method called fill NA, which basically takes all the empty records, it's only 1 in this case, and fills it with the first result there. Okay, so if we again, fare should no longer be missing, so it's no longer outputted. So we updated that correctly. Now the question is, was that right or not? That's the whole point of this competition. I could have spent a month working out a complex algorithm to deduce his age based on something and get my accuracy 0.1% higher and move 1,000 places up the competition ladder. That's the whole point. You don't know when to stop and you don't know how much time to invest in these things, but the domain knowledge is critical. This is just an example of how to do these things. If you knew all the answers, you'd get 100% prediction, and then you're probably in the wrong business if you can predict things that accurately. So we've still got missing ages, cabins, and embarkment, and we're going to ignore cabins, so we've got age and embarkment missing. So embarkment is a categorical feature. It's not a number. It's one of the 3 places where he got on. So let's have a look at those 2 records. So we don't know where they got on. They're both females. So let's see where the most people got on. Okay, most people got on at Southampton. So there's a higher probability that these guys got on at Southampton. But no, it's very hard to say. So also notice that they both survived. So we could do a crosstab with survival and embarkment point to see if there was any particular location which led to a better rate of success, because we know both of these people survived. So here we can see that, interestingly, people who got on Southampton did actually have a higher probability of surviving. If you look at the percentage of that versus that, that's actually lower. They actually had a lower probability of surviving, because there it's pretty much 50-50, but there they had less chance of surviving. That's actually, it looks like another bug, but you get the idea of how to replace the kind of analysis you could do. We'll just assume that he's from Southampton, and we'll fill in A on embarked with S. So now we'll check that we have no more missing nulls, and we'll use the describe feature again. And we'll just switch it to display because you can't see everything. It takes in a data frame, so sorry, it's not going to work either. Okay, so sorry, coding while doing a demo. Okay, so we're looking for making sure that our embarkment points have no missing counts. So 1, 3, 9, that's correct. There's no more missing values there. And the last missing value was age. So we could replace it with a median or the median by class. But let's have a look to see if there's something else. So if we do a box plot on class, we could see that there's a bit of a difference, that people in first class were older. So if we know that this person is older or not, maybe that's a good way to a good probability we could use the class to get the median age. There's definitely a bit of bias there towards age. But what we could also do is we could look at our data set again, and remember we had let's just show them all again. So if you look at the name, you'll see that it actually has the title of the person. So there's no point if the person was a Mr., that he was going to be under 21 years old, for example, or if he was a master, he'd probably be under 18, depending on the way they categorize the titles at that point in time. So this title would be quite a good indicator of their age, probably more so than class. Or we could use title and class to make even higher probability guess. So this is not a feature. So now we're actually going to do a first bit of feature engineering. We're going to extract the title from the name and make our first feature called title. So here I'm using a user-defined function, and it's basically it's a Python function that takes in a column, and for each value it'll go and do something and return it. So we're going to do data frame with columns. So we're talking about we want the column title, and we're going to say run the existing data frame name through this function, and that's going to be the title. So basically this takes the name and splits it on a comma, then splits it on a full stop, and it extracts the first half of that. So if you look at our data frame again, you'll now notice when that was created, we now got 11 fields. So even though I said df equals df with column, it didn't modify the data frame. It dropped it and recreated it. It's completely immutable. It cannot change the data frame. So here at the end, we now have got this title, and that's going to be that extracted value. Okay. So now we've got this title. We can say show us the number of people in these different titles. So immediately we can see misses were the most. We could change this to we could display this and put it into bar chart to visually see that Miss was a lot and Mr. was a lot. We also got some people out of all the passengers. There was just one person who was a Don, John Keir, the Countess, Donna. Like these are all very archaic titles, and they might skewer our machine learning. So what we could do is say, let's reduce them down to the main category. So we're just going to do replace on the whole data set and say where it's these less common ones with one people, we're going to categorize them in different bins. Mr. Officer, when it's a military title, because possibly if you're a military person and you're on the Titanic, you'd say I'm going down on the ship for an honor, you know, like that's again domain knowledge. I don't have that domain knowledge. So we're now going to massive replace, and now we do the same group by title and show the count, and we can see we have way less values, distinct values in that category of title. Okay. Now we can get, for each of those titles, we can also go and get the average age, the mean age. So you can see that generally the military people were older, which would make sense. A master was 5 years old, Miss was around 20, 21 years old, and Mr. and Mrs. were slightly older. I mean, these days, this would probably be a little bit higher for Mr. and Mrs. So we live longer. So we'll do another box plot on title and age, and we can see that there's definitely a lot more variation here. So we've got more accuracy by using title to infer our age than we did before. Okay, one of the challenges I came across was I was unable to find a way to do median very easily. So we'll use mean. So if anyone wants some homework to do, try and do this with median. It's really difficult. In pandas, it's pretty easy. So we're going to do this by, there's two ways of doing this. I'm going to show you both. So you basically do a join between the mean age, which we set up here. We made a new data frame called mean age, which is this data frame. We're going to join them together where it's null, and we're going to say if it has a value, use that age mean, and if it doesn't have a value, which means that it has an existing value, use the age. Okay, that worked fine. There's another more efficient way that someone told me in Stack Overflow after I presented them with that. It's partitioning. So we can use the order bound partitioning, and that's a much more concise way of doing it. If we look at the output of this, we'll see that we now have this new column, age mean, and the age will have the mean age filled in where it was null. There was none null here. That's why it doesn't look so different. Okay. So now we're going to confirm that the bar column has no more nulls, and you can see that everything has the right amount of values except for cabin, which we're not going to use. So we'll write this back as Titanic not nulls, and we can continue. So if anyone has to go, I'm very aware that it's 1:30. Feel free to go. I'm just going to carry on a little bit longer. We're not going to get to the machine learning part here, but I want to finish the data munging part because it's quite interesting. But feel free to go if you do have to go. Thanks for listening. Okay, so we're going to load our file again. Uh-oh. It's really weird. My cluster just literally disappeared. This is not the cluster I was using. I was using the machine learning one, and it just literally disappeared. Okay, well that's probably a good place to stop the mystery of the disappearing cluster. So let me just skip ahead to what we missed. So basically we'd then fill in our data, we'd look at the derived features and do some feature encoding, we'd make some more features like with the title. I won't go through that now. Feature encoding, it's a big topic. I won't go through that now. And then we'll get to analyzing and modeling the data. So machine learning is basically you're looking at the data for patterns, and that's called training. You take these patterns and apply them to data where you don't know the outcome, and that's the machine learning part. Okay. So a classic example of this is spam detection in emails. Someone said if an email has all these different input values, that are otherwise known as predictors, it's probably spam. And they never know if it is or not. It's the probability. If it's above 80%, let's say it's spam. So that's the business rule. You'd say if it's above 80%, we'd say that it's spam. Now, this Titanic problem is binary classification because there's only two discrete labels, survived or did not survive. A regression problem would be where you're trying to predict a continuous value, like the mileage of a car, for example. It's not a state of 1 or 2. It's a number that could be anything. So this is a non-regression problem. We call it supervised machine learning because we know the input and the output, so we can train the data set. As opposed to unsupervised machine learning, which is where we only know the input and we don't know the output. So you might have a situation where you want to group your customers by who are the best spenders or who are the best customers to send mails to. And you don't know what you're looking for, but you can categorize them based on their amount they've spent or whether they come back again. Recommendation systems, kind of like that. You like this Netflix film because you're in a group of people who like this other film. So that's unsupervised machine learning. I won't go through this. I won't go through this at the moment. Now, in this case, presenting the data, the outcome would be the CSV file that we would submit to Kaggle, but you might have a presentation to stakeholders to say, this is where we could save ROI on our process. I'll give that a skip. Okay, so takeaways. There's a lot of data engineering that has to happen before you can get to the machine learning, and I think the fact that I ran out of time demonstrated that. We didn't even get to the machine learning part. We just cleaned data and got it ready, and that's the same with any process. I'm happy to come back and do this as a second part. The other thing is that domain knowledge is absolutely critical. You could see all the guesses I was making, and you can keep refining. You can keep refining your guesses and checking your accuracy because you know the output of the training set. This workflow can be applied to many other data science problems. Databricks is awesome. Python's pretty cool too. So if I'm say it again, start playing with it. It's pretty good. The technologies we used in these demos was SparkML for the machine learning. You could use scikit-learn. There's thousands. You could use TensorFlow, and maybe that would influence your accuracy. They all have ease of use and accessibility and API, that kind of thing to consider when evaluating it. There's a cool technology that I was going to show you in a demo, which is called Koalas. It came out about a week ago at the Spark AI conference. So people who use pandas in the data science world, they're very used to that API. And then they want to use Spark or Databricks for distributed processing. And they find that the API is really different and you can't do things like get the median really easily. So the Databricks team have put together this open source library called Koala, which matches the Panda API, but it does do distributed processing. So you can do a .info, for example, and behind the scenes it is actually running it across multiple clusters. Pandas doesn't. It only runs on the master node. So it wouldn't scale well with millions of records. Now, a lot of my learnings came from a Pluralsight course called Data Science with Python. It's very, very fun. It's a 6-hour course. It took me about 2 months to finish. It's average when you have a 1-year-old. But it uses pandas and scikit-learn. So I adapted it using Databricks and SparkML. So, are there any questions? Can you check if any written questions, please, Ollie? So, don't go. You didn't actually see the machine learning part, unfortunately. So I put there, what is it, Apache Spark.net. I just mentioned this. So also from the Spark AI Summit, they've announced that they want to include .NET as one of the languages in Spark. So you can do R, Python, SQL, Scala, Java, and C#, which would be awesome. So I like Python, but it's not a typed language and or statically typed language, and it's annoying changing syntax. They have different naming conventions for everything. So I would love to write in C# instead of Python. And that'll be built into Databricks. So yeah, I'm looking forward to that. Yeah. So any questions on what you saw?